Hello, hello. I know we're running a little bit early. I wanted to make sure that all my stuff is working, so just bear with me. I am watching the chat, so if you have any questions, go ahead and pose them. All right, let's just see if this works here. Hi. Yeah. Let me see what that looks like. All right. So let's see what that looks like. We are going to start at 6 or a little bit after. I just want to make sure all this is going well. We're going to have a good time. Okay. Doesn't look like that is showing up, so that's good to know. Black. Huh. Okay. That looks like it's showing up. Perfect. So we're going to use this because we're going to do some stuff kind of on the fly. So we'll be talking numbers and such. So if you have any questions there, that will be good. It looks like just another couple minutes. If you have any questions, drop them in the chat. And we'll get going here shortly. Hey guys, welcome. Welcome. If you're there, I'm just testing everything out. We are going to get going here shortly. I think we're going to have some fun. If you have any questions, drop them in the chat. This will be fun. We'll have a lot going on. So 6 o'clock. We'll wait just a couple more minutes for a few people to hop on. If you have any questions, drop them in the chat. I'll see what I can do about checking along the way, and we'll kind of go from there. I'm going to refer to a couple things. One is ChatGPT. We're going to talk a lot in generalizations, but I think there's still going to be something that comes back. Hey, Ben, how's it going, man? Good to see you. And then, but you're definitely going to have something to take away. So, like, we're going to talk real live numbers. And let me see how I can say this the best way I can is I'm going to ask ChatGPT on some of the not only incidences, but even pricing. And then with my knowledge, I guess, of the industry, I can kind of say, oh, yeah, that's in the ballpark. And then we'll go from there. So, yeah, if you got any questions, comments, anything you want to see me cover, I don't really have a time frame on when I'll leave, but nonetheless, it should be fun. Looks like I'm having just a little bit of trouble here. So if you can see me, definitely just drop something in the chat because it looks like it's being a little bit goofy. Okay. All right. Well, we got a few people on. This should be fun. So here we go. All right. For those of you that don't know me, my name is Brent Wright. I am a clinician with East Point Prosthetics and Orthotics, and also I'm a partner in. Oh, Brian. Hey, man. Also a partner with Advanced 3D. And so we're going to cover a couple things today I think is going to be helpful. And we're going to talk real live numbers. And then we have some I'll break it down for you. So the first thing we're going to talk about is considerations. And then we're going to have some environmental considerations, why you may 3D print. We're going to hop into foot orthoses. We're going to talk about foot orthoses, some of the incidences. Then we're going to talk about the actual cost of traditional fabrication, the actual cost of SLS, MJF, milling costs. We're going to talk about reimbursements. And then we're going to play a game called Let's Pretend on the foot orthoses. And then we're also going to, in that same one, we're going to say, does it make sense for the foot orthoses? So we're going to do that same thing for SMOs. And we're also going to do that for AFOs. And we're going to do that for transtibial prostheses. So we're going to cover a ton. But nonetheless, this is going to be fun, is my hope. And, something at least to think about. So here we go. I'm going to start my PowerPoint presentation. And we're actually going to do this. Present, share screen, entire screen. Here we go. Share. Okay. So we've got some considerations to make. The first consideration when you're talking about 3D printing and such is, hey, do you have a technician? Okay. Do you have a technician? And then the next thing that you have to ask when you're talking about technician is, are you do you truly know what the cost is? Okay, so you take your technician and then you amateurize that over a period of time. So it'd be good to look at their salary, break it down to weekly, and then take a look at some of the material costs that go along with that. The next thing that's very important is, do you have a scanner? And then what is your budget going to be for the scanner itself? So you can start with something simple like Comb Scan that is on your iPhone. It's sub $1,000. There's also something called the Einstar scanner from Shining 3D, also sub $1,000. Both great ways to get going. Now, my preference is the ArtTech Eva, and it's just great. It is the kind of the Swiss Army knife for all scanners. You can scan inside, outside of cast. You can direct scan, all that. So that is my preference when you're looking at scanners. But this is super important to think about, and it's something that you need to go ahead and have ready to go in. The next thing is, hey, what is your time worth? So a lot of clinicians, they love to be in the the um, the lab. They like to do plaster and that sort of thing, and that's okay. Um, However, there have been some studies done. Well, I say studies loosely, where contract manufacturers look at what is the how much is the employee's time or employee or time worth or a clinician's time worth, and we're talking in the magnitude of lawyer time per hour. So 250, 300 plus dollars, depending on your revenue intake. So when you go back into the lab and you go modify for a couple hours, that means you're literally burning probably a minimum of $600 just there. So it's definitely something to think about. Do you know how to design? Do you want to design? Same sort of thing is if you want to design, that's great. And then you have a myriad of options to do that. My suggestion is you look at something that is going to allow you to have the clinical expertise to make the device that you want to make. And there's a myriad of ways to do that. And there's some great apps to do that. So do that. You don't have to buy this massive yearly subscription thing. Um, a whole bunch of other options. You While subscriptions in themselves aren't bad, just know, hey, what are you actually looking for? What is the goal? Do you know what you're doing? So this is I put a smiley face behind it because for those that know, like I really enjoy memes, and this is not a slight to our field at all, but it is something that you have to know that you want to do something. So uh, do you actually know what the modifications that you're doing traditionally, and can you translate them to something that is digital? So, for instance, I had a scan of a unrectified model, scan of a rectified model, and I asked the clinician what they had done, and they told me what they did. I overlaid it, and what they thought they did versus what they did was different. And that was very surprising to them. So that's all things that you have to consider. Be honest about the real costs. That is super important as well. Is yes, the materials may be $100, but then are you actually including the technician's time? And are you including the realistic time to make something? So that is one thing that's interesting, and we'll look into that a little bit more. But I think what you'll find is that for some of these devices, it'll be actually a lateral move as far as pricing. So you're not going to necessarily save money. However, you may free up time. What are your pain points? So this is probably one of the most important questions to ask yourself is, are your pain points really solid ankle AFOs? Because my guess is probably not. You may do a lot of them, but those are kind of the lowest um, difficulty brace to make. So, and there's a lot of options to do that, both in a traditional sense and plaster or carving, and you're still probably going to come out cheaper for something like that. So what about post processing? So if you really wanting to get into 3D printing, how are you going to finish these devices, because that is an extra cost? Hey, let's talk about capital investment. How much is it truly? That's an important part. Is there a return on investment? That's also important. What about maintenance? There's a lot of maintenance that goes on um, with these devices, and are you including that in your costs? Are you already sending out your casts and modifications? So this is a really really important point, because if you already are sending stuff out, then more than likely whoever is receiving your stuff is doing some sort of digital modifications to that. So if nothing else, you can save by UPSing or using the postal service or whatever your shipping is, at least one way. I mean, that is a great option. I see a couple more people coming in. Okay. So so none of these really talk about how 3D printing uh, it really excels. And I think the main thing is about midway down, what are your pain points? And then the other thing that I think is important that doesn't get talked enough is the environmental considerations. Now, I had Jan Nielsen on my podcast not too long ago, and he was talking about the excessive amount of water that is needed for traditional fabrication. And it was actually slightly sickening to know how much water just goes to waste in a traditional process, and then what that is saved in the 3D printing. And then with a traditional fabrication, you have a ton of waste, and there's not a lot of recycling. So a lot of people ask about, well, what about recycling plastic? So I've looked into that actually, and any plastic recycler that is wanting to make money, so this is not just feel good, but like actually wanting to make money, they are not going to take your garbage can full of plastic. They just aren't. They will take a 40-foot container full of plastic. So when I had the conversation with them, it was like, okay, so how long is it going to take to fill up a 40-foot container? And the reality is, it's just not plausible. Even for a small or regional company like ours, we're not going through that much waste. So water is a big deal, waste is a big deal, but here's something that people aren't talking about a lot. So okay, so you use technically less waste for 3D printing. Um, However, what about the spools that the filament comes on? There's no way to recycle those right now, or if there is, drop something in the comments. Let me know. But you see these massive stacks of plastic spools. It's not really great. And then you have a lot of companies really pushing the idea of PA11. It's from a castor oil bean. It's not petroleum based. However, PA11 is tiny, tiny particles. It's great. You get a great resolution. However, it is super hard on machines. If you talk to any contract manufacturer, they almost hate running PA11. That's just the case. It's super hard on the machines. Um, it's super hard on the cleaning process. You're going to go through more parts on your machine. The cleaning, it's just a big deal. So the reality is, yes, while the castor oil bean is technically uh, good for the environment and all that, it's really tough on the machines. And so I think it probably evens out, but it does cost about 30% more than PA12. And just remember that when you're talking about petroleum-based products, we're talking about a byproduct of petroleum that's already being used. So in a sense, it's kind of one way, one half of the other. Uh, Thank you, Ben and Taiwu. I think it's great. The plastic's probably not that great for what we do, but I think it's great. I think it's important to talk about it, and the reusable spools. I think that's super important as well. So, and then so we talked about the recycling there. So I just wanted to slide that in, though, is that this idea uh, is not all glorious for 3D printing saving the environment. There are some other considerations, and as the it matures, the industry matures, I think we're going to see more and more benefit, specifically around the water thing. I think that's probably the biggest thing. So let's just be honest about uh, the truth about what the environmental considerations are. All right, now let's get to the fun part. Foot orthoses. Okay, so let's start off with just um, foot orthoses. There is nothing. A foot orthotic does not exist. Okay, so the true name of it is called a foot orthosis. If you want to be singular, foot orthoses. If you want to be plural, there is no such thing as a foot orthotic. Orthotic is an adjective, and I know you say, "Well, Brent, it really doesn't matter." I mean, you're right. It's not a hill that I'm going to die on, but I think it's important for people to know. And then when you're talking to people in our field, if you come into my clinic and you call it a foot orthotic, I know that you're not really speaking my language. And I think that's a big deal. So, this is where I said I took into consideration a couple of things and I queried ChatGPT for some of this data. And whether the data is real or not, it's kind of irrelevant because we're going to dive into some of the costs. I think the part that is relevant is once we get to the cost savings. So with foot orthoses, according to ChatGPT, you got about 4.5 million per year. Traditional fabric, 4.5 million of these per year. All right, let's talk about traditional fabrication, speed, cost, that sort of thing. The reality is traditional fabrication, you pour these molds down, you smooth them up, you know, let's call it by the time you've got them actually finished, you may have an hour in that a pair. And there's people that can do that much faster. And your cost, just materials, is probably going to be in the $5 range. So not nothing too crazy. So you have an hour of labor, $5 in material cost, but you can do something really quick. So literally, you could do same day turnaround. Send somebody home, and they can get their foot orthoses. So when we're talking about 3D printing, we're not talking necessarily at that speed for some of these things, um, because of and other than, and we're going to get to the FDM side of things. So traditional fabrication, yeah, not too crazy as far as pricing, but it does take a lot of time, but they're not difficult. It's a kind of a lower skill um, to achieve. So that's kind of an entry level technician, and then you go from there. The thing about these is that a lot of these are going to be um, diabetic insoles. And so we'll get to that shortly. All right. So SLS, multi-jet fusion, cost, speed. So let's just remember a lot of these manufacturers will say, hey, it takes this long to print. Well, if it takes that long to print, it usually takes that long to cool as well. So the reality is, at minimum, you're not even getting into a build for 24 hours. So on the smaller frame, SLS machines, you may get up to um, 13 to 20 pairs is really really pushing it, and that's extreme density when you're talking about the smaller build volumes of the SLS machines. These SLS machines, you're looking at per kilogram, probably about $100 per kilogram. And the small build volume of machines are going to be roughly 6 kilograms, and you're going to be able to recycle 70% of that. And we're going to look at that here shortly. Multi-jet fusion costs, the same thing. So for the 5200 series, you're going to be able to get into that build probably in about 24 hours. So you're looking about a 12 to 13-hour print time. Maybe faster if you print in the fast print mode, but you're still going to have to cool. So 24 hours pretty much is going to be the max time before you get into that. And then again, you may be looking at 60 pairs going into a build, and that's going to be seriously a dense build, not a lot of powder to recycle on that side. Milling costs. Oh, and then multi-jet fusion. Again, even though I own a multi-jet fusion, I did not look at our pricing. I went to Chat GPT, thought about it, and said, okay, yes, that's probably about right. The powder cost is roughly $70 to $100 per kilogram. The build volume holds about 30 kilograms, and you can recycle up to 80% of that. So milling costs and speed, you're looking at a machine that there's different pricing, but anywhere between 14 and 30,000, you're going to get a pretty reasonable machine. You're talking about a machine that's going to produce a foot orthosis at least every 10 minutes. So it happens really, really fast. It's a great option. And then on the back side, you do have to put, and on any of these, you're going to be putting a top cover. And then FDM, you're looking at the max. You could probably do 2 per hour, so 1 pair per hour on some of these machines. And this is where it gets very interesting. So some of these machines, depending on the size and depending on what you're doing. So if you're doing 3/4 length foot orthoses, you've got less materials. So you probably sub $3 in materials for a pair, and you're going to be able to crank out 1 pair per hour. And that's at best, okay? And then you can, if you're running 2 shifts or if you have some automation, you're doing well. So the reality is FDM for foot orthoses is kind of where it is. Let's take a look at the reimbursement for the 30/20s for the foot orthoses. So Medicare reimbursement. All right, Medicare reimbursement. I'm going to go to my trusty. Let's get back to here. All right, so Medicare reimbursement. I'm looking at the chart right here, straight from CGS. I'll put this in my computer here. Okay. To make myself a little bit smaller. Okay. All right, let me make this a little bit bigger because you probably can't see that at all. All right, so an L30/20, Medicare reimburses. Well, kind of funny. So Medicare says it reimburses $227.83. But unless you're diabetic, you're not gonna see any of that. So I'm just gonna put that down here, L30, and you're gonna see what I'm doing. So 227, and then L80, 5513. So A5513. Let's just it's actually up here. Let's see if we can capture that real quick. All right, so we're looking for A5513. If you see it, holler. There we go. $52.13 is what you're going to get. Okay, that's each. So now we're going to play a game called Let's Pretend. And this is going to be the fun part. All right. All right. So here we go. So supposedly we will get $227, so roughly $450 a pair for foot orthoses, but Medicare doesn't really cover it. And so most insurance companies follow Medicare guidelines. So if people are paying cash, usually they're going to pay somewhere about 300 to call it 450 for a foot orthosis. So not too bad, but you really have limited all your market. I mean, most of the foot orthoses that you're going to make are diabetic, which are at $52 a pair or $100, roughly $100 per pair. Okay. If you are wanting to be a good business person, you want to keep your cost of goods at roughly 30% is kind of a general rule of thumb. So that means for either one of these, for the regular foot orthoses, you want to keep your cost of good 30% of 400 is, let's just call it COG at 140 or under. And your COG on the 8513, let's just say 35 or under. Okay, so super important numbers. Remember me talking about the FDM ones? You're going to make some good money on either way you go FDM. SLS, kind of the going rate that I've seen, at least for wholesale, just shells. You're probably looking about $60 if you buy them from a place, and I would say the material cost alone, not including machine costs and all that, of both SLS and Multijet Fusion, is going to be in the $20 range. So for functional foot orthoses, still makes sense. You put a top cover on it, and you're going to make some money. For the diabetic foot orthoses, your FDM or your SLS and Multijet Fusion, you're pretty much out, not even possible range. And so here's the other part that's super interesting when it comes to this. Okay, if I have the option of paying, and I'm doing this in house, say roughly $3 plus a top cover, so $5 for a pair of foot orthoses in house, and somebody is going to pay me, let's just say at the bottom part of that range, $300 for a set of foot orthoses that are the 3020s. I have zero reason to consider any other technology other than traditional fabrication. Milling is still, you're going to be, probably sub $10 in material, and then FDM, you're definitely going to do that. My margin, if you're a business person, you want your margin to be as large as possible. So I'm looking at trying to make the foot orthoses for the least amount of money in the quality that I expect, in the timeliness that I want. So let's create a new one, a new board, and let's just take a look at the actual the time frame. So let's just say we've got 4.5 million people that need foot orthoses. Okay. So we just said that in the SLS small frame unit, you're pretty much going to max out. Let's just call it 15 pairs per 24 hours. Okay? And so this is SLS small. Let's call large. Let's call this on one machine. Let's say you max it out and you can turn it one time in 24 hours. So that you're talking about 120 pairs per 24 hours. Okay. You following me so far? I think this is fun. I'm sorry if it's boring you. I guess you can leave if it's boring you. All right. So we said that there was 4.5 million. So let's just do some quick math. Um, let's see, calculator. All right, we've got a calculator here. Here's the math. We got 4.5 million. And my assumption is that's going to be pairs as well. You don't really do each. So 4.5 million people are getting foot orthoses. So if if you're running your multi-jet fusion or your SLS or your whatever equipment it is, so let's just start with SLS. So you're getting 15 every 24 hours, and you're going to run that 7 times a week. We're assuming 100% uptime. 100% uptime. It's 105 per week. And now you're going to multiply that by 52. So that's 4,000 or 5,460. So let's just have some fun. 4 divided by 5,460 equals. That means we need 824 small frame SLS machines. I can see why, somebody wants that. But let's just say that's the case. If an SLS machine is running at $70,000, you're only talking about 57 million, $58 million in revenue for foot orthoses. And you'll never get that revenue again. What does that mean? I don't know. Let's get to that on another slide. All right. So let's talk about the multi-jet fusion or similar size SLS machine. Yeah, Tewu. Oh yeah. FDM definitely you're there for sure. All right. So let's just pretend that you get 120 pairs in a day times 7 times 52. So you're looking at 43,680 per year. Okay. Very cool. So let's take that number. So let's say 4 million divided by 43,680. It's 103 machines. 103 machines. Let's just say at 103 machines, and these machines, I checked ChatGPT again, are around $400,000 each. Talking about $41 million in revenue that you're never going to see again. Now, there's material revenue and that sort of thing. So really interesting number, right? And we'll get to that in a second. Now, let's just do the FDM machine, because if you go 3/4 inch or three quarter length FDM and throw a top cover on, you could probably do a custom bamboo printer with some ways to automate it to get it off. You run those 24 hours a day. You're still only going to get 24 per day times 7 times 52. So you're at 88,736. So you're actually better than an SLS at that point. And then the curious thing, so if you're at 4.5 million divided by 8,000, and your yield is never going to be 100%, but we know that it's only 515 printers. Okay. And that times the Bamboo A1 is roughly $400. So you're looking at $206,000 to serve the whole US market of bamboo printers. So pretty much every single time FDM is going to win here. So let's get back to there we go. We're going to make me bigger, and then we're going to go back to the PowerPoint. Okay. So there's the, let's pretend. Display settings. We're going to swap presenter. So we're going to go here to, so photosynthesis, does it make sense? Okay, Felix says the most people tell that recycling starts to make sense only if you have a 3D printing farm with ABS. Yeah, I mean, agreed. Like some of these other materials, you're not even going to recycle. Most of this stuff is going to end up in a dumpster. But the waste is less than traditional fabrication. So I never want to lose sight of that, specifically for water. All right. So photosynthesis, does it make sense? Man, that's a traditional manufacturing makes sense if you have a technician. FDM makes sense for photosynthesis, SLS, and the big or small. I mean, that's a tough one. If you're maybe running it yourself, maybe, but yeah. So take what you want from that. All right, man. That was a long time on the photosynthesis. Sorry, guys. Let's get to some actual other numbers and let's see if we can keep this show going. Okay, so SMOs. There's roughly about 500,000 per year. Traditional fabrication, your speed. I would say that some of these big companies, guessing again, very educated guess, I would say, is 200 to 300 per day go out the door. So you've got your SLS and multi-jet fusion cost speed. If you can keep that, and then milling costs, more like along the milling of the mold. And then let's talk about reimbursement. So 500,000 per year, that's pairs. Traditional, again, from ChatGPT, kind of makes sense, just doing some basic math. You're able to create these, but it's typically they're pediatric. They're kind of a pain to create. So if you can outsource these pretty much at all costs, yes, do. It's a traditional fabrication. Yes, you can do same day, but most of the time you're talking about on truly custom, probably about a 2-week turnaround time. On something that's by measurement, traditionally fabricated, you're looking about a 4 to 5 days, sometimes stretching out a little bit further. And you're going to do, yeah, I would say about the same for the SLS. Let's just quickly talk about the reimbursement of these. So when you're talking about reimbursement, yeah, I would say, and I'll just cut to the chase. You get about anywhere, say from $400 to $600 each. So on the top end, about $1,200, on the low end, about $800. So when you're taking a look at your cost of goods. Now, with this, you're okay with the cost of goods a little bit higher. So let's just say let's call it the middle of the way um, of the cost of goods for an SMO. Let's say you get $1,000 for your orthosis, which is an L1907. You can add some other codes to bring it up a little bit, but let's just call it $1,000 for speed's sake. You can go up probably to 45% cost of goods. So if if you know you're gonna get $1,000, you could go up to about $450. Now, traditional fabrication costs usually, if you're going to outsource these, are going to be up to about 350-ish dollars, plus or minus a little bit for shipping. So you've got a little bit of meat on the bone to play with there for a pair. And I would say it's pretty much a lateral move cost wise for anything SLS, MJF going there. So, um, let's pretend, right? So, does it make sense? If you're outsourcing 100%, it makes sense to do it 3D printing. And let's just be honest here, the FDM SMOs, they just don't look great. So you're really talking about multi-jet fusion or any of the powder bed fusion stuff is going to look great. Sometimes you can do like a TPU or only TPU, and your cost of goods is going to be all right. So it definitely makes sense in the SMO range. You've got a few options here. You've got Spenties that does a cool thing where they take stuff from a cast and measurement, and you get something going. It's really slick. Invent Medical does some things by measurement, and then of course there's SureStep that does things by measurement on the traditionally fabricated side that you're able to do. But it's going to be a lateral move. I see those costs coming down as the volumes go up. So this is one where it does make sense. Just getting this out of your lab and going from there. All right, let's talk about AFOs. This one should be a fun one too. About 1.2 million per year. And I would say this is probably each because sometimes it's one-sided. So people that have MS, some sort of traumatic brain injury, stroke, that sort of thing. A lot of times it's one-sided. So traditional fabrication, speed cost. This is where things get really interesting. So with any powder bed fusion, you have very small. You can't just put big things in. So like a solid ankle AFO is never going to make sense in a powder bed fusion. The cost is just too much. So let's just talk cost real quick, and we're talking generally speaking. Again, my Chat GPT example. So let's say you're fitting an adult AFO. We know chair heights are usually 18 inches, so your AFO maybe is 16 inches tall. Well, you're maxing out the box of the powder bed fusion printer already at that rate. So a solid ankle AFO on the low end, and we could go in there, it's an L1960. You're going to get maybe somewhere between $450 and $600 for that brace. So when you're talking about 30% cost of goods, you're talking about 600. So you got to be in the 180 range, 180 to $200 range for an L1960. You're definitely going to be there in the milling or traditional fabrication. You're talking about a $10 piece of plastic, some plaster, some time with the technician. It's your sub $100 easy if you're doing it in house. If you're doing it out of the house, you're still sub $150 easy. A solid ankle AFO adult makes 0 cents every day of the week. Never do it. I don't know why people would do it. It just is that way here in the US. So solid ankle AFOs, thumbs down, 0 out of 10 stars. Never going to make sense. Unless you like losing money. But we're all in business to, I know we're helping people, but we're going to make a little bit of money as well. Okay, so that's AFOs. Now, here is some other things to consider, though. We talked about solid ankle AFOs, but these are all AFOs. So these include the dynamic strut AFOs. These include like a PTB style AFO. So there's some other ones that may make sense. So when we talk about pain points, let's do that real quick. Strut AFOs are a pain to make. So my favorite strut is from Coyote Design. If you traditionally fabricate that orthosis, you are pretty much telling your technician you need to take a half to 3/4 of your day to make that one brace. It's a terrible use of time. And to be honest with you, they just look handmade. You know, these strut braces, you're going to have cast saw marks, that sort of thing. And even traditionally fabricated in the carbon fiber, it just looks handmade. And the carbon fiber is going to delaminate. It is what it is. So let's pretend this is one thing where it makes sense. These strutted type of AFOs absolutely make sense because you may be into this depending on the design, automation, that sort of thing. Say $700 to $800, and then you add the strut. So let's just say it's sub $1,000. You're already going to be $400 under any other traditional fabrication if you're sending that out. And you're talking about a 2-week turnaround time or less, especially if it's modified quickly or automated quickly. So you're paying less, you get it faster, and it's going to last longer. So kind of a no lose situation. And guess what? Instead of at a 50 cost of goods, now it actually puts it into your position where you can make a little bit more money. So when we're talking L codes, you're this is where it gets a little bit interesting. So you could be an L1960, and then you add the strut, and then you could add like a pretibial molded shell if that's what you're going to do. You can add carbon fiber for the strut. If you're wise, there's ways that you can add carbon fiber for the proximal and distal pieces. And then there are some people, and this is not billing advice, okay? So there are some people, and I do not disagree with this. I probably more agree than disagree, that use an L1970 to describe this brace. And you may ask, well, that's jointed. Well, what does a joint mean? It articulates, it moves. Well, what does a strut do? It articulate, it moves. Totally possible. Totally could see it. And I would have no problems with somebody going that way. Again, your mileage may vary, but that's the direction that I would go. So when you're talking about smaller pieces, you can get a lot more of those in the machine. You still are going to want to outsource. You're not going to want to bring this in-house unless you're doing a crazy amount of volume. But the reality is these things don't nest amazing. So you're still going to have to bring other parts in for it to make sense. So it still makes sense to outsource these. Okay, so we just pretended a little bit. I hope that helps you out a little bit on the AFOs. Solid ankles do not make sense. Pediatric solid ankles may make sense because they're a lot smaller. And they're super pain to make, traditionally fabricated, and they're quite expensive when you contract manufacture them. So with some of the big pediatric clinics or contract manufacturers out there, it's going to be pretty expensive. And so you may want to look at 3D printing through, say, a Spenties or an Invent Medical, or even some of the stuff that we're doing at Advanced 3D would make sense, not only financially, time-wise, at least a lateral move, but you're creating something that is a differentiator. All right, transtibial prostheses. This is going to get interesting real quick. Roughly, again, ChatGPT, probably not a terrible number. Maybe it's a little bit higher, but let's just go with it. 25,000 per year. Traditional fabrication speed and cost. This is where you have to be, realistic about how much it costs, how much time. So people, yes, you can turn these around same day in traditional manufacturing. You're never going to do that with multi-jet fusion. And there are some clinics that specialize in this particular style of fabrication where the people may come in from out of town or what have you, and you need to turn something quickly. Um, Traditional manufacturing is going to make a lot of sense. However, FDM could make some sense, especially when you're looking at high flow for some of this stuff, at least on the test socket side of things. And we're going to get into that in a little bit. So, SLS. And so, okay, so we're talking about carbon fiber, and I'm just going to say, hey, if you're already sending these out, you're probably spending anywhere from $600 to $1,000 just for a laminated socket. I would say for a multi-jet fusion socket, SLS, you're going to be kind of a middle of the road there too. So very much a lateral move. Does it make sense? Maybe. The milling costs, I mean, so if you're talking about a test socket or something, you can mill something in just a few minutes, pull it, and out the door in about an hour. It's really hard to beat that. But again, you've got to have skilled labor to do it, that sort of thing. So reimbursement, this is where things get interesting. Let me see. Let me get back here. Let me just see where I went. Okay. All right, so let's go to let's pretend. So let's just say definitive sockets, right? You can get a few of these in. You can get one into like a small um, SLS printer, one if you're lucky, and I would say you could get up to 3 or 4 in a larger format powder bed fusion. So when you're talking about a cost of just material costs, right? So at scale, yeah, you're probably both SLS and the larger format. You're still probably looking at best case scenario, roughly about a $300, $250 to $300 cost. That's if you know how to design. And I would say that's reasonable. That's something to think about. But let's talk about these codes, and this is where things are going to get interesting. And Ben, this is where your comment really comes into play. Test sockets is considered L5624. I won't pull it up like I did with the foot orthoses, but I think this is important. In the US, we get paid for test sockets. So any company that is out there saying, oh, well, you don't need to fit a check socket, I get paid for fitting check sockets. It's a good clinical tool to make a final definitive socket. So there's no reason not to fit a check socket. So in the US, I'm just talking US, part of the workflow needs to be a check socket. All right, so a check socket, if you're using a regular piece of plastic, some people will seam Vivac, pull it, either polypropylene. There's some companies that make plastic and rings. You're probably talking about $30 to $40 per piece of plastic, plus some time with the mold. A carved socket is roughly 30, so let's call it $20 to $30 for foam, and you can reuse that maybe once. So on the bottom end, your test sockets are going to be traditionally fabricated. Let's just call it $70. So $70 on a $300 return. Fantastic. I mean, that's pretty good. So there's not a lot of reason not to traditionally fabricate, and there's no reason, I think, not to have test sockets in-house when we're talking specifically about 3D printing. So now let's go to Ben mentioned pellet printing, and then we can talk about the high flow printing, like what Filament Innovations does. This is pretty important. So with Filament Innovations, you can do pellets, and you're probably talking about a material cost of like $5. Okay, maybe a little bit more than that, but not a lot more than that. And then if you're using filament, you're maybe about $10. So actually, the pellets may be less than that. Now, your machine cost is going to be more expensive, but look at that spread. Okay, if you're doing the design, your um, your material cost versus what you get reimbursed is a great spread. It's better than traditional manufacturing, and so your return on investment um, happens very quick. And I actually did a podcast on this with Jen Rosati from Kenny Orthopedics, and they calculated that the return on investment, it happened very quick. They're high volume, and so when you think about it, is let's just say on a let's just take it. Let's just say it's $20 per socket material cost. So let's just say I think the Filament Innovations pellet machine is roughly $50,000, maybe a little bit more than that. Don't hold me to it. So you're putting away $250 per test socket, so $1,000 per 4 test sockets. So you will pay for the machine 50 times 4 in 200 check sockets, and then your check sockets then become $20 a piece after you've paid for the machine. That is pretty good. So, but you got to be a higher volume person. But there are people 3D printing check sockets that are a lateral move for regular style sockets, or regular like contract manufactured sockets. So I think that's pretty interesting. So test sockets, 100% traditional fabrication or FDM is going to make sense. FDM, massive upside. It's perfect for that. You're going to get a return on investment, especially at a higher volume. There's zero reason not to do those in-house. And especially at the high flow, you're getting sockets in an hour and a half, and you're still able to see patients and all that stuff. So literally somebody can come in the morning and they're walking out either late that morning or after lunch, and you're good to go. So it makes sense for these clinics that know that they need to do stuff and push stuff out for the day. All right. So the regular socket is at L5301. I think I can do this. Check my Excel spreadsheet. Okay, so let's do a control F, L5301. Oh, oops. L5301. All right, so you're talking, so that's Alaska, which is high. Let's just go over and find North Carolina real quick. Of course, I didn't grab the. Okay, so this is probably more in line. $2,700 for definitive socket using the L5301. So $2,700. $2,700. If you're, say, go 30% cost of goods, you're looking at, you've got about a $900. You can go up there. 100%. It's going to be a lateral move for you. You're going to be spending that anyway if you're doing contract manufacture. Yes, it might be a little bit less if you do it in-house. So 100% makes sense in SLS or any larger volume one. Pretty much only when you're outsourcing, though. It's not going to make sense to bring prosthesis in or bring a machine in for this. And we'll talk about that in just a second. Now, this is where things get really interesting, and this is where we talk about the pain points. Click Medical really did amazing job getting a code for adjustability. And this is, really important because the L5783 now is approved and it goes on top of the L5301. So you get an extra roughly $3,000 for putting adjustability on the socket. So now you're talking about a $5,000 to $6,000 socket. So at 30% cost of goods, your cost of goods can be, I would say, $1,500 to $2,000 to do that code. And now this particular type of prosthesis is such a pain to make. You're pretty much telling your clinician or your technician, I don't want you doing anything else for the day. You're going to be working on that socket. It's really a poor use of time, technical time. So for this style of socket, it's an amazing use of additive manufacturing, specifically powder bed fusion. There's no other way to do it. The sockets that are traditionally fabricated, they look handmade. Again, you're going to see cast cell marks, uh, either wavy, not symmetrical, that sort of thing. It doesn't matter how good. There are some amazing technical people. There's going to be some sort of display that it is handmade and it's just a difficult socket to make. So for adjustable sockets, 100% it makes sense every day of the week to be making these with powder bed fusion. All right, we're getting to the end here. Does it make sense? We just went through that. Let's see if there's any questions here. All right, so I know the big question is, let's just talk in generalities. In fact, let me go back to that original slide. Oh, swap it. All right, capital investment. Capital investment for a small SLS machine. Talking about $70,000 probably, maybe a little bit less. $100 per kilogram. So there's a couple of interesting things about this, though. Okay, so when I asked ChatGPT, I'm going to try to get this my iPad back up here. ChatGPT about this. Let's see here. Okay, so we got that back. So it said about $70,000. So okay, so that's not terrible. But remember, you're only getting one socket in there, and you're talking about a minimum of an one full day to get in there. So at well, we'll do that calculation in just a second with my iPad. So on the larger format, you're looking at same 24-hour turnaround time at, like, that's pushing it. The reality is that's not realistic. And you're really not doing this for time. It's for other reasons. But so the annual maintenance on the smaller SLS machines, you're probably sub $5,000. The annual on some of the larger SLS machines, you're talking about $15,000. And then on some of the multi-jet fusion, again, ChatGPT told me this. I'm not showing you any paperwork that I have or anything else. You're in the $25,000 to $40,000 per machine for maintenance, and those machines run 400,000 plus. You can find used machines, but you're still going to be in for the maintenance and obviously for the materials. So we'll talk about that in a second. So let's take a look about, well, how much does it cost? Um, a lot of people, well, I just Brent, I just want to have it in house. I just do. I get it, but you're better off learning how to be an amazing designer and use the extra capacity that is available literally nationwide on a myriad of machines. You're going to be out so much cheaper. So let's just take the smaller format machines here. We're talking about 70K and $5,000 a year. So, and then you've got 6 kilograms of powder at $100 a kilogram. So you're talking about $600 for the first build, and then you're recycling about 70% of that. So per build, you're looking at, so 30% is 180. So 600 minus 180 is 420 per build. 420 per build. Okay. You still have to include the machine cost. Okay. So let's just have an honest discussion about that. So machine um, at even at 0% financing, let's say you're $1,000, $1,000 a month. Yeah, for 72 months. Okay, so 1,000 per month, and then you add the 5K, so you're at 1,500 a month for the maintenance plan too, and then $420 a build. If you do, um, let's say 5 sockets a month, you're at 2 grand, some change plus 1,500. So you're looking at 4K a month for a small SLS machine. Actually, not when I'm looking at these numbers, and I haven't done this, I haven't done this calculation before. I'm just kind of rambling, I guess, but really not too bad. Um, not a terrible, not a terrible investment. So there you go. And then you get to run some other parts, some fun parts, that sort of thing in there, maybe some tools for the lab or what have you. So I think that's all great. So let's do another one here. All right, so let's go with a larger machine. So we're talking about SLS machine, a multi-jet fusion machine. These machines are roughly 380 by 380 by 300. Let's just call it 300. So, and a lot of them on the low end, you're going to be at 400,000 for the machine, and then 15 to 40,000 for maintenance. Okay. And then we're just going to pretend that all of them take about 30 kg in powder. And we're also going to pretend that that powder is roughly $100 a kg. Yes, you might be able to get it in bulk, but let's be honest, if we're doing prosthetics, it's not going to be in bulk. Like, we're not doing contract manufacturing. So you're going to be paying the higher rate. So I hope you're following me there. So $100 a kg. So you're talking about, for that initial build, you're talking about $3,000 for the initial build. And then per build after that, you're recycling 80% of that. So 20% new is coming in. And so 20% new, 20. So you're talking about $600 per build in materials going forward. That's not including post processing. That's not including the machine. So 400,000 amortized over 72 months. Let me do that calculation real quick. 400,000. Oh, I guess I could do it right here. Oh, they don't put a calculator on the iPad. Interesting. 400,000. I'll just do it on my phone real quick. Divided by 72. So you're looking at $5K a month in just having it on. Actually, 5,500. And then let's go to the higher end, or not the mid range. Say $20,000 a month. So another 1,500. So just to have that machine in your building is $7,000. Just to have your machine in the building. Okay. Let's say you do. This is where let's say you get 3 sockets in per, and let's just say you're doing 150 sockets a year. So 3 sockets in 150, so that's 50 builds at $600 a piece. So 50 builds at $600 a piece. This is where stuff gets fun. I haven't actually run this math. 50 builds times 600 is 30,000. So that is making. So we'll just say 30,000 divided by 12 is 2,500. So for under 10 grand a year, so $120,000 a year, you get 150 sockets. So you're looking about. Now this is just material costs. 100 and so we'll just call it 120. Divided by 150. So you're looking at 800 and some change per socket. Not terrible, especially if your return, like you're definitely in the 30% range. I think that's pretty interesting, bringing in a machine. But just remember that, okay, so that's your material cost. Now, if somebody is actually doing contract manufacturing, you're going to be able to get it less than that. So bringing a machine in-house, unless you're a big manufacturer in the prosthetic side, probably doesn't make a lot of sense. Where it really makes sense is focusing on the design itself. So we went through a lot, and I think even I learned a lot through some of this. So we'll do a quick recap here. One is powder bed fusion doesn't make sense for foot orthoses. It just doesn't. The math doesn't work unless you like to lose money. It just is what it is. Or I take that back on the lose money side of things. If you're making $450 per pair of foot orthoses, 100%, go to town. Hey, Brian. Yeah, man. Take care. So if you're making that per, that's great. But just remember that FDM, the spread is much greater. So why not? Why would you pay more for the same amount of reimbursement? That's just that. Okay, so for foot orthoses, FDM makes sense. Traditional manufacturing makes sense. Milling makes sense to keep everything within cost of goods. Okay, cool. Let's move on. SMOs make sense. FDM really doesn't make sense unless it is the TPU. The TPU actually looks pretty good, and I can definitely see a hybrid. If you're going to do a foot orthosis that's hybrid, like a frame and a TPU insert, then by all means go for it. The AFOs, Never makes sense with solid ankles for adults. Just is what it is. For kids, it kind of makes sense, especially if you're going to go color. Kind of makes sense. And then your pain points. So any of the strutted AFOs absolutely makes sense. Any things that are difficult makes sense. Pediatric stuff also makes sense there. And then for transtubular prostheses, uh, makes a lot of sense. You're going to be a lateral move anyway if you're already contract manufacturing, but um, especially when you talk about adjustable prostheses, there's no reason not to do it. And there's more meat on the bone there for sure. And the product is going to be better than any traditionally fabricated product. Now, there's other ways that we can go. There's a whole host of other things. That was only 4 devices, and it took an hour and 20 minutes, and I didn't really think that I'd go that long. But that's just, I mean, when we talk about upper extremity prosthesis, holy moly, that's a different discussion in itself, and maybe one that we should have. But thanks for hanging in there on a Sunday, and I appreciate you all contributing as well. If you have any questions, I'll hang on just for a little bit. I hope you appreciated the candid nature of this. This is not a slight to any OEM that is providing these devices. Hey, I thought of that, but man, there's so many different options, Ben, about the upper extremity. But I think absolutely, like if you found this interesting, I think I should actually do that. So, anyway, guys, thank you so much for being on. That's all I have for today. Take care.